To Galantis Academy. Today we'll be talking about chemical bonding, right? Basically, we're supposed to start, as I promised you guys, that I'll start from beginning, but the beginning part is about chemistry, what chemistry is all about, which I think most of you should have known what chemistry is all about, the kind of careers you can find in chemistry and all that, right? So I choose to start from chemical bonding, right, so as to establish a kind of confidence in every one of you watching this video. Now we have to understand why chemical bonding is important, right? After talking about why it's important and all that, I will define what exactly chemical bonding is. So first of all, why do we need chemical bonding? Why is it a topic in the first place? Now, as you are as a person, you love being stable, right? Both financially stable, health-wise stable, right? Academically stable, right? You love being stable, and whatever that will affect your stability, you love to actually discard it, right? Take for instance, when you lack money, when you don't have enough money in your bank account or whatsoever, you try as much as possible to work harder, right? Whatever profession you're doing or whatever job you're doing, you tend to work very harder, right, in order to balance it, right? If you're sick, right, you tend to visit the hospital so that you will maintain a very, 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 very standard health, right? You have to be stable health-wise too. Okay, the same way it is to atom love, like they tend to be stable too, right? Most atoms are unstable in their lowly state. Do you get? Okay, here's what I mean. Let's take for instance oxygen, right? Oxygen, which is represented O2. O2. So now, if you're writing, like, if we are told to list the first 20 elements, what are you going to write? O, right, and not O2. So why do we write O2 when representing oxygen? Now, here's the difference. O is an atom and O2 is a molecule, right? O is an atom, O2 is a molecule. So oxygen tend to appear in its molecular form. Why? Now let's draw the formula. We have oxygen, right, which is 8, right? Hydrogen, helium, lithium, beryllium, boron, yeah, oxygen 8, right? 8, which is equal to 2, 6, or you can just simply write 1s2, 2s2, right? 2p 4, if I'm not wrong. Yeah, 2p4, exactly. So since both of them are in the same shell, right, we just classify it as what? As 6. So you can have something like this first. So we have one of the atom, or one of the electrons, sorry to say, one of the electron, another electron. Remember that 2 will be the first one, 2 will be here, and 6 will be other place. So here, right? 2, 4, 6. Exactly. So this is how the shell configuration is. Now, as it stands here, right? This is not stable, right? It's not stable. An atom can be stable if it has 2 electrons in the valence shell. This is the valence shell. Valence shell is very easy to understand. The last shell is known as the valence shell, right? So an atom can only be stable if it has two electrons in the valence shell or 8 electrons in the valence shell, and that's what come about the duplet and the octet rule, right? The duplet and the octet rule. So that's it for that. And if you should count this very well, you will notice that this is 6. 1, 2, 3, 4, 5, 6. So it's not complete, right? It's not complete. So it can go in two ways. It can either lose the 6 electron or gain 2 electron. But to be frank, which do you think is easier, losing 2 electron or losing 6 electron or gaining 2 electron? Which do you think is easier? Anyway, type in the comment section, tell me the one you think that's easier, and stating your reason, right? And let me just chip in this. Interacting with the video matters a lot, right? Whenever I'm teaching and I ask a question, comment in the video, right? It's not much to jot down, right? You can always access this video anytime you feel like, right? But always comment down. Oh, this. Okay, that's by the way. I will tell you the answer to this as we proceed. Do you get? Okay, now what I'm trying to establish is that chemical bonding is all about balancing or satisfying this rule, that is the duplet and the octet rule. Do you get? So whatever we'll be doing here is trying to say, okay, how can you lose, and what type of losing is this? When it loses electron, what's it called? When it shares electron, what is that called? And also the level, the strengths, right? How these electrons are how these bonds are so strong. Do you get that? So that's exactly what chemical bonding is all about. So now, what's chemical bonding? Can you try that? Pause the video, comment in the comment section. So chemical bonding refers to the formation of a chemical bond. So we know that a chemical bond is formed. A chemical bond is formed between two or more atoms, molecules, or ions to give rise to a chemical compound. These chemical bonds are what keeps the atom together, right, in the resulting compound. So whenever a bond is introduced to two molecules, two atoms, it forms a compound. And when we leave it, it stays the same way. Reason because a bond is still present. Exactly. So now let's move to the types of bond we have, right? I will for this video is cover just ionic and covalent bond, right? It's called just ionic and covalent bond. In subsequent video, I'll talk about the hydrogen bonding, the other ones, and so on, right? Let's move on. Okay, now types of chemical bonding. All right, can you try? Just try. No harm in trying. What are the types of chemical bonding we have? It's very simple. Now, they are actually divided into two categories. And what are they? The intermolecular bond and intramolecular bond. Very simple to understand. Now I will break it down so that you will understand, because one thing about chemistry is not good for you to cram. No, it's not good. Understand what they are talking about. All right, let's move on. Now, intermolecular bond, that is, this is the kind of bond that are found between molecules, just like interhouse spot, right? That is a kind of spot that houses play, that maybe, let's say, greenhouse, blue house, like I said, they play against each other. That's interhouse spot. Do you get that? Now, this intermolecular bond, that is between what? Two molecules. Do you get that now? So when they say intramolecular bond, so for the biology students here, this won't be very hard concept, or those who are very good in English, right? When I say intra competition, intraspecific competition, do you get that? So that is inside the molecule itself. That is, this happens between atoms. Do you get what I'm trying to say? That is, this intramolecular bond happens between atoms. So I can also say intramolecular bond are also known as interatomic bond. Do you get the point now? All right, so I can also say interatomic bond. Do you get this? I can also say what? Intraatomic bond. Very simple and straightforward. Now let's proceed. Now I will talk on for this video I will talk on intramolecular bond alone, right? And just pick out two out of it. So what are the types of these intramolecular bond? Can also be subdivided. And what are they? That's between atoms. Try. What kind of bond can we find between atoms? First is what? Ionic bond. Ionic bonds. The second one is what? Covalent. And the last one is what? Dative. Dative can also be known as coordinate covalent bond. Do you get that? All right. So for this particular video, I'll talk about ionic bond and covalent bond. So what's an ionic bond? What are also covalent bond? Type in the comment section so we'll proceed. Oh yeah, welcome back. So let's talk about ionic bonding really quick so we can move on to covalent bonding, right? Ionic bonding, or ionic bond to be precise, is actually the strongest bond ever, right? It's the strongest bond. Do you get that? And you should note that whenever we're talking about bonding generally, right, it has to do with the valence electron, right? It has everything to do with the valence electron. So here's it. I'll say a brief about the ionic bonding, give you a definition about ionic bonding, then we'll treat just one or two examples, then we'll move to covalent bonding. A specialized video for examples will be posted later on, so ensure that you click the subscribe button, right? You like and also join our group, our general group, in order to stay informed. All right, let's move on. When you say ionic bonding, what does that really mean? Like, what comes to your mind first? What is the first thing that comes to your mind? Kindly comment in the comment section. Now, when we're talking about ionic bonding, we're actually talking about the transfer of electron, right? The transfer of electron. Apart from that, the ionic bonding has everything to do with metal and non-metal. That is, electrons are transferred from the valence shell of a metal to that of a non-metal. That's what the ionic bonding is actually talking about. So now let's know more about it. So what's ionic bonding? Ionic bonding is simply a type of chemical bonding which involves a transfer of electron from one of the atom or molecule to another. Do you get that? Here, an atom loses an electron, which is in turn gained by another atom. Which such an electron transfer takes place, one of the atoms develops a negative charge and the other a positive charge. I get it. All right, so let's talk more on it. The second point I gave was that it occurs between a metal and a non-metal, right? And in this kind of bonding, one of them, an anion, right? An anion and cation are formed. An anion and a cation are formed in this kind of bonding. Now let's take a look at an example, because if I give you an example, you'll be able to understand and retain my teachings for a longer period of time. Okay, let's use an example that we all know about. And what's that? The NaCl, your table salt, NaCl. So this NaCl is actually an ionic compound, right? It's an ionic compound. Okay, good. It comprises sodium and chlorine. Good. So for the sodium, what is the atomic number? You can try. Comment in the comment section. 11. Correct. What of chlorine? Can you try? 17. Very good. We all know this now. What's the next step? We have to represent it in the electron configuration, right? We have to write out the electron configuration for us to know how many electron is actually in the valence shell. Let's do that. So we have the nucleus. Good. So this is for sodium. Before I proceed, let me tell you why I drew 3 shell instead of 5, instead of 6. Now, let me tell you now. Now this is 11. The first is 2. The second is what? The second shell will contain 8. While the third shell will contain what? 1, 8, 9, 10, 11. Do you get? Now, I know that some of you watching this video are actually just finished secondary school or probably don't really know how I got this particular guy, right? It's very, very simple and straightforward. If you don't understand it fully, please refer back to the organic chemistry video. I explained it in details, right? Refer back to the video on organic chemistry. I explained how we can get 281 in detail, right? But for this video, we have to be as fast as possible, right? So for this is what? 2, 8, and 7. Do you get that? This is 8, right? 8, 2, 10 plus 7 is what? 17. You get it now, right? All right, that's fine. So this one also have what? 3 shell. 3 what? 3 shell. All right. What we'll do next? So for here we have 2 will be here, 1, 2, 8 will be here, 1, 2, 3, 4, 5, 6, 7, 8, and the last one what will be here, right? Or the second one we have 1, 2, 3, that is 2, 3, 4, 5, 6, 7, 8. Is that complete? And last one what? 7, 1, 2, 3, 4, 5, 6, 7. Do you get it now? So now, remember I told you about duplet and octet. All atom in chemistry love that state because it's a stable state. So whatever reaction that you be performing in chemistry, everything is to achieve what? This singular act, the end product, which is what? To contain 8 electron or 2 electron in the valence shell. 2 electron or 8 electron in the valence shell. Is that clear? All right. So now for the sodium has only 1 electron, 1 valence electron. So it has to be 8. It has to have 8 electrons. So how can we do that? How can we achieve that? Is it better for it to lose 1 electron or to gain 7 electrons? Can you try? Comment in this comment, write your response in the comment section. Okay, for chlorine now, which do you think will be easier? To gain 1 electron or to lose 7 electrons? Which one do you think will be easier? Definitely correct, to gain 1 electron for chlorine, and for sodium to lose 1 electron. Is that clear? Good. Now let me show you how the reaction will look like. So we have Na, right? So it has to lose 1 electron. Do you get? So it will be like this: Na plus E minus. Now for some of you racking your brain, how can I learn this thing? How will Na give Na plus? Don't worry yourself. That's why you're here. Let me tell you how we get that kind of answer. You know that this sodium, this stuff is sodium, right? Is that not true? Okay, write this sodium now. Then instead of saying this Na, right, I want to say minus E minus. You know this electron. Sure you get. This is electron now. So now I'll now say minus 1. And instead of me writing 1, no need now. They taught you in mathematics. So I just write E minus will give what? If it loses 1 electron, that means the proton will be more now. Sure you get. The proton will be more. So it becomes what? Na plus. Do you get that? So now we like removing the negative. Anything negative, we like removing it ahead of time. That's why this has been what? Converted to this part in here. Do you get logic now? Very, very simple. Now, what of chlorine? Now, chlorine will gain an electron. Is that not true? Yes, it is. Now, let's see how it goes. Cl, it has to gain 1 electron. So it's plus E minus. It's true. We give what? Cl minus. Are you getting the point now? Cl minus. Now I told you that in ionic bonding, anion and cation are very, like, we observe anion and cation, that is, they are present. Good. So now this is Na plus. What do you think Na plus is? Is cation. Cation. And what is this? Anion. So what does this anion and cation mean? The video at Gallant Tutors is to make you understand. I guess to make you understand. So that's why I'm breaking everything in details. So for cation, what do you think cation is? Cation is the full meaning of cathode ion. Cathode ion. Do you get that? So cathode is negative. True? Cathode is negative. So any electron or any compound or any ion that will be going to the cathode has to be what? Has to be positive. Do you get it? It has to be what? Positive. Good. That's why Na plus, which is positive, is also known as what? Cation. The same thing go for anion. Anion means anode ion. And anode is what? Positive. Sure, you understand? So that's that for that. So now you can say that the electron that has been lost by sodium, right, has been gained by chlorine. Do you get the point? Has been gained by chlorine. Do you get the point now? So this is actually what? An ionic bonding. There is a transfer of electron. Do you get? That is, so at the end of the day, sodium is happy and chlorine is also happy. That is that. Now, what of, and I'll give the answer later, what of CaCl2? How do you think this kind of bonding will be? Will it be ionic? Will it be ionic or will it be covalent? If it's ionic, state your reason for your answer. If it's covalent, state your reason. Though I've not explained covalent, so by just jot it down somewhere. CaCl2. I get it. That is calcium chloride. Good. Let's move on to covalent bonding. Now, quick one. So, what does covalent bonding really mean? When we say covalent bonding, what does it really mean? A covalent bonding indicates the sharing. That is, in covalent bonding, there is sharing. There is no transfer. Please, these are key points. If you are writing work, there are actually key points that you must take note of. So in covalent bonding, they talk about the sharing, isn't it? So a covalent bond indicates the sharing of electrons between atoms. Compound that contain carbon. You understand what carbon means now? Like also like what do you call it? The organic compounds commonly exhibit this type of chemical bonding. The pair of electrons which are shared by the two atoms now extend around the nuclei of atom, leading to the creation of a molecule. So in ionic, do you get? Actually, a compound is formed. But in covalent, molecules are formed. Please take note. Molecules are formed. Good. Now let's have a little bit of an understanding. Let's take some little example. I'll just give you 2 examples so you'll be able to understand what I really mean. Okay, I will take the first one will be CH4. And for the fact I say that carbon compound undergo covalent does not mean they are the only one that undergo covalent bonding. Please take note. Alright, now let's look at covalent bonding now in methane. This is methane. CH4 is methane. Refer back to my organic chemistry video. Now for for carbon, it has an atomic number of 6. Good. It has an atomic number of 6, so it will be what? 2, 4, right? So we have the nucleus. We have this. Can you see? I'm drawing 2 what do you call it? 2 shells because they're what? 1, 2. You get the point now, right? So let's move on. So for the first one, we have 1, 2, 3, 4, something like this. This is how it will happen, right? Sorry, this will be only one. Please take note. Only one here. So 1, 2, 3, 4. Correct. So now we have hydrogen, right? Hydrogen is the first element now. So it will have only one electron. Is that not true? So it will have what? This will like H, right? H, good. H, right? H, something like this, right? So just let's just make it formal. So we have one electron in front of it, one electron here, one electron. In short, one electron in front of everything, right? So let's look at it closely. Let's assume we don't even understand what covalent bonding is. Let's assume that first. What kind of bond can this be? All right, let's look at it now. If hydrogen lose an electron, it will not be duplet. It will not be an octet. No, now it could work now. Do you get? So hydrogen cannot sacrifice himself. He cannot lose. Yes, now. Okay, now let's look at carbon. Can he actually sacrifice himself and say, okay, don't worry, hydrogen take, so you'll be happy with your life? Let's check. Okay, if hydrogen lose one. No, hydrogen, that is carbon. If carbon lose one, carbon will also not be happy. So the only thing they will say, okay, let's come to an agreement. Check, I share it 50-50. Let's share it 50-50. That's what this guy is telling them. So now we are going to be sharing it. The electron will be shared between both atoms based on my definition, right? Based on my definition. So in actual sense, this is how it will be. A bond will be formed, a bond will be formed, a bond will be formed. This is how it will be. That is, the one electron here is forming bond here. This is also forming bond. This is forming bond. This is forming bond. Right? This is forming bond. This is forming bond. Right? You get the logic now. This is exactly how it is. Now let's talk about another one, which is the one you all know, ammonia. Ammonia. Good. This is NH3. NH3 is ammonia. Is that not true? Now the central atom is what? Nitrogen. How will nitrogen be like? So nitrogen has an atomic number of 7. True, right? So it has 2 and 5, right? All right. So we have this. That is it's going to have 2 shell only. Good. So we have 1, 2 here. We have 1, 2, 3, 4, 5, something like this, right? So hydrogen, just come and put your hydrogen here. No stress. So use the same format. Can this lose? No, it cannot lose. It cannot. I get it. So what will happen here is also what? The same sharing. So if you look at the structure of ammonia, it's something like this. Right? It's something like this, which is what? A trigonal pyramidal shape. I will talk about the shape in further video, right? So if you look at, you can see how it has a kind of pyramid shape. Do you get the point? So it's trigonal pyramidal, right? So that will be all for today. I hope you enjoyed it. If you enjoyed, please share, please like, right? Comment. In short, do everything to ensure you interact. It's not for our own benefit, but for your own benefit. And also comment in the comment section the video we should produce next. That is, make a suggestion. Oh, I want you to produce a video on mathematics or whatever. Just comment whatever you want in the comment section, and whatever I find interesting or whatever, just comment in the comment section. It helps us to improve also. Thank you so much for watching. We love you all. Thank you so much.